chapter 5, there's a couple ways to attack this chapter. I like thinking of it as math modeling. So I've kind of written my notes to be more about math modeling. But I'll try to still cover some of the concepts. And I think by creating the homework videos, that will also help me break it down to more algebraic. But I try to stay away from being heavy algebra in this part of the course, and spend more time talking about how we use different types of equations to solve different types of problems. I feel when we teach algebra, we stick to doing equation after equation after equation and solving it a bunch of different ways, right? The problem is we don't do that in real life, right? We don't. I've been doing math for a lot of years. When I was in the Army, my last 5 or 6 years in the Army, I was a data analyst for the Army. And no one has ever come up to me and asked me to solve an equation. Instead, they've come up to me and said, we have a problem and we need your understanding of mathematics to help us solve this problem. And that is what chapter 5 is, right? Chapter 5, we're going to talk about the foundation of these functions, but I'm not going to spend a lot of time going into the why, right? If you want to understand the why, then after this class, take Math 122 College Algebra, and you'll get 15 weeks of understanding why you calculate all these horrible things. Instead, I want to show how these things work in the real world, right? So we'll kind of talk about this, and then I'll do some of the whys in the homework videos. And so 5.1 is probably the toughest of the problems in chapter 5 because it lays out to the definition what functions are. And it is challenging to wrap your head around until you've done it for a while. I'm comfortable with it, and it's not because I'm smarter than you, which the students try to tell me all the time. You can do math because you're smarter. No, I understand functions because I've done it longer, not because I'm smarter, right? It takes a minute to wrap your head around. The first time I learned them, they didn't make a lot of sense to me either. So to help explain a function, I came up with this example that has no math in it, right? Because that's what functions are, is just it's a function, a model of a problem, right? And we use this a lot in computer programming, engineers, so that's where the functions are important, but in reality, they're everywhere. So to do my best not to get beat up by my nurses here, I'm going to simplify breathing. I know there's way more to it, but we're going to simplify it. So the human lungs, we're going to call as our function, right? And to survive, we need to breathe. And so to make, again, I'm simplifying the problem here. We need oxygen, right? So I'm just going to write O2, right? We need oxygen to survive. And of course, we breathe in and we breathe in way more than oxygen, right? And then our lungs process the oxygen and do all this biology and get it to our blood and all that stuff. Again, different class, but it does something. And then we exhale, and typically what is it, CO2? I think so. This part I think I got right. We exhale carbon dioxide, right? In the simplest terms. So our body has taken something and has changed it, right? And then it has done something with it, and that is all functions are. And so what it is a function is something comes in, the formula does some calculations, and it gives out a different output, right? And so the way we think of functions as the input, what is going in is called the domain, right? And that is independent because nothing has affected it yet. Then the equation, the system, the function is going to take that analysis and it is going to do something to it. And then it is going to give you a result. It's going to give you an output. And that output is called the range, right? And it is a dependent variable because that result is dependent on what the function did to it, right? So if you kind of think of a function as that, as something comes in, some process happens, and then a new result comes out, right? That is a very simple of how the lungs work, but also very, very simple understanding of its function. So when you're thinking of functions, think of that. I have something that comes in. I do something, something comes out. Now, with functions, what you have to be careful with is you can break them, right? And just like our lungs, we can breathe in something that can kill us, right? So we want to limit those bad things coming in because it will be harmful to us and break our function. And the same thing comes with mathematics. In these functions, there are going to be values that will break the formula. And we got to be careful not to use those formulas. So the problem is going to say, hey, define what the domain is. Tell me what my limitations are. And so when it says define my limitations on my domain, what it's asking you to do is say, hey, what is the limit of the numbers that can come in, right? And because there is a limit on the numbers that can come in, there is therefore a limit on the numbers that can come out, right? Some functions have no limits. Some functions do, right? And so that's what we're going to talk about. So I'd like to spend a few minutes on it because this is one of the lessons I think is really hard to wrap your head around when you first do it, because it's definition heavy, right? So I do have listed here the definition. So a function is a mathematical equation that describes the relationship between a dependent independent variable for a given solution. Very math heavy. Think of it as just that. It is a formula, right, that takes something in, does calculations, spits something out. Independent variable is the value that is substituted into the function that will solve the function. You will get a result. The dependent variable is the results of the function, right? What does the equation equal? And so when it asks for domain, this is the hard part. It wants every possible answer. A lot of times when I ask for domain, someone will say the answer is 2. Well, yes, 2 is one of the values at work. Is it all the values? Oh no, there's also 3, right? So that's what makes domain challenging. The answer is all, not some, not one. You must list all of the values, right? So everything that can come in as well as everything that can come out. That is the range. And there's lots of ways to do this, and we'll talk about the different ways to do it. I don't have a preference on which method you use to show these things. And so we'll talk about the different ways here in a sec. Questions on the concepts of functions before we kind of move on? I know we haven't done any calculations yet, so we've just done the concepts. So here is a example I just came up with of a linear function of shipping. So a lot of shipping is got kind of this function, right? And so say we're a shipping company, and if an item is 50 pounds or more, so if it weighs more than 50 pounds, right, it's going to cost someone to ship it $20 flat rate. Like it weighs 50 pounds, you must pay $20 to ship this thing, plus 35 cents for every additional pound, right? So when we do functions, a lot of times we name the function as 2 letters. A letter on the outside, typically a lot of times you'll see F, right? I know I always make cursive F, so sorry for that is a cursive F. It's a standard for function, but it doesn't always have to be. So you can see I used S here, and the reason I use S is it's shipping cost. So I said shipping cost starts with S, so I put an S. And then the thing in parentheses is your independent variable. That is your domain. So X is the independent variable that is in this function. And S of X, this is a symbol. A lot of people, when they start doing this, think this is some number. It's not, it's a symbol. That is one thing. This is what, until now, in most of your algebra classes, we always called Y. Now, can you just call it Y? Of course you can, right? If you don't like writing S of X or F of X or G of X, and you like, I like my Y, fine, make it a Y. I don't have a preference. I want you to be able to use a function more than write it out this way. So that is a symbol. X, and so this is our dependent variable. This is the result we're going to get out. X is our independent. And the easiest way to figure what the independent variable is, it's the letter that's inside the equation, right? So if we look at our equation is $20 flat rate plus 35 cents for every pound over $35. So I created the equation for you. You didn't have to create your own. But X is the variable that's in the equation. So therefore, that is the independent variable. So now, how do we use this thing? So mathematicians were lazy, right? We don't like to write a lot of things out. This is probably why I have horrible handwriting and I can't spell, because I didn't have to write. S of 50 is just the same as saying, what does X equal? I mean, what does the function equal when X is equal to 50? So the way I like to think of it is you have a 50 inside where there used to be an X, right? So therefore, I put an X. I mean, sorry, no, I don't put an X. I put a 50 where the X is. So now I just solved this thing. 20 plus 0.35. I don't know why I put the parentheses there. Let me fix that. Parentheses. Put in 50 for X. And now I do 50 minus 50. And I pick 50 for purpose here. You'll see in a minute. And now I just solve this. Well, 50 minus 50 is 0. 0 times 0.35 is still 0. So this whole thing just equals 20. I put 50 in, I get 20 out. So then think about it. Let's go back to the problem. If an item is 50 pounds or more, it costs $20 plus 35 cents for each additional pound. Well, if I bring something in that weighs 50 pounds, then there's no additional fee because it doesn't weigh over 50, but I still have to pay the flat rate of 20 bucks, right? So the function works to what the problem's telling me to do. So that means the minimum cost is going to be what? $20, right? As long as my item's 50 pounds. If it's less than 50 pounds, there's a whole different equation. We're not going there, right? We're sticking to big packages here. We only ship big packages. So what happens if someone brings in a package that weighs 63 pounds? Well, now we just put the 63 where the X is. So 20 plus 0.35, 63 minus 50 equals. Now we just grab our handy dandy calculator, right? Do what's in parentheses first. So 63 minus 50 is 13. So I'm going to do 13 times 0.35. And then I'm going to add 20 to that. And I get 24.55. So someone that brings in something that weighs 63 pounds, they got to pay $24.55 to ship it. And we do one more. What if we'd have 40? Well, there's an issue. 40 minus 50 is negative 10. And so that's why we have this limitation right here, right? X has to be greater than 50 to use this equation. X 40 is not greater than 50. So this is not the proper equation, not the proper function to use this problem. So therefore we don't use it. So there is no answer to this one because it broke the function. It was not part of what this equation was meant to do. So based on this information, what is our domain? What can X be? I always forget to escape.
Would it be that X has to be greater than 40?
Not 40,
I'm sorry, 50. Sorry.
There we go. Yep. So X has to be greater than or equal to 50. So I can write this as what we call algebraic notation. I'm just going to write this way because I don't want to mess with the limitations of one note right now. So that is how we call algebraic notation. X is greater than or equal to 50, right? And typically we don't write that way. We write it like I did up here. X greater than equal sign with a line under it for equal to 50. This is what we call algebraic notation. If you've taken other math classes, you might have learned something called interval notation, where you can put in, what is it? It can go to infinity, which I'm not going to try to get my thing into math mode right now because it'll take forever to get out of it. So infinity looks like a sideways 8, comma, and then 50 is my low end. Actually, I should write it the other way. Shall we start with a smaller number first? 50, comma, infinity. And then when you include a number, it gets a bracket, and then infinity gets a parentheses. So that is called algebraic notation. I mean, interval notation. I have not really used interval notation a lot. I have seen it basically since I started teaching at the college level. Some of you, if you've gone through, Math 030, Math 050, you've maybe seen this more. So if you're comfortable with interval notation and you want to use it, fine. If you're comfortable with algebraic notation, fine. If you want to explain it in words, fine. As long as you understand what the domain is in this case, and the domain means I have to be 50 or larger. Now I'm going to move some of my stuff around. All right, so if 50 is the smallest number that can come in for X, what is the smallest number that can come out?
Is it 20?
It's 20, right? And that's why I picked 50 here at the beginning for a purpose, right? So I know my function, which is S of X, has to be greater than or, no, wrong symbol, sorry, greater than or equal to 20. And how do I know that? Well, if I take the smallest number that can go in, 50, I put it into the function. Well, if that's the smallest number that can go in, then 20 will be the smallest number that can come out. Yes, no, confusion? And again, if you want to write it as interval notation, that would be bracket 20, comma. Oh yeah, that's why I didn't type it last time. I have to draw the infinity symbol. Infinity, parentheses. Or I know it's going to be $20 or more. And so this is used all the time, right? In Amazon, they have a function, right? If you're a Prime user, then you get free shipping. But if you're not a Prime user, I don't know what the going rate is right now. I think it's 50. I'm a Prime user, so I don't know how much you have to pay for shipping. But there's a shipping cost unless you spend so much money, right? Walmart's the same thing, and Walmart's like $35. As long as you spend $35 online, your shipping's free. So they have functions. So when orders comes in, the computer figures it for you. They don't have a person there doing the calculations, right? They built a function in the computer. So when a person places an order, they know exactly how much to charge them for shipping based on size of package, weight of package, where it's going. And they have a threshold, they have a domain where if you spend this much money, then the value is the shipping 0 and you don't have to pay anything, right? So the functions are used all the time. And a lot of times we write them for computers because then computers can do all the calculations for us, but we have to define the function for the computer to do the calculations. The computer is not going to create the function yet, right? Right now, we still don't have things that can do that. Right now, we still have to tell the computer what we want it to do. But once you have your function, you put your function in the computer, You give the function a domain, the computer can figure out the range by knowing what can come in. It knows then what can come out. Questions before we do one more example? Oh, I wrote that with the wrong pen. Dang nabbit. I used the Zoom pen instead of my OneNote pen, so now it's going to be in my way. I'm just going to put it down real quick in case if people want to go back and look at my notes. 0.35, 50 minus 50 equals 20, then 20, 63 minus 50. That was what, 24.44 if I remember correctly off the top of my head. Anyway, now you have your notes. Now they stay there.
2455.
Ah, thank you. 24.55. Thank you. Remember to use the right pen on this. All right, so if we have no questions, then we'll do another one. So what if we had the function, and I already have this typed out, so I didn't have to make a messy handwriting. Move him over here for a minute. I'll come back to him in a minute. So we have this function 3x squared plus 25. All right, so x is our independent variable. The function is 3x squared plus 25. So now what if I get if I have -2, -1, 0, 1, and 2? So there'll be a couple homework problems where they'll give you a function. They'll put it in table form for you. Go away table. And so I have it done here just so you could have the neater notes without having my horrible handwriting. But what you'll kind of see on the homework is it may give you a function. So they say the function is 3x squared plus 25 f of x. And then it says x here, and it puts it will pick the numbers for you. And what it wants you to do is fill in the rest of the table, right? And if I remember correctly on the homework, they'll have some of the numbers done, so you only have to do a few of them. You have to do them all, right? So I always do 0 because 0 is easy, right? Because if I put 0 in for x, 0 squared is still 0. And then 0 times 3 is still 0. And so 0 plus 25 is 25. So just like Hawks, I did one of them for you. What I would like for you all to do is see if you can find, you don't have to do all four. Pick any one of these four numbers I left you and tell me what the answers are, please. And I will do all four because I'm going to cheat because I'm going to use Excel. Because Excel makes things way quicker. And then we'll compare answers anyway, because that way I can, this is probably the biggest part of functions is being able to put them into your calculator correctly. And this is a way for me to see if you can put it into your calculator correctly before I release you on your own to do the homework. So 3. And when someone thinks they have an answer, they can either put it in chat or just tell me what x is and what they think the function, tell me what x you use and what the function was.
I mean, I have no idea because I can't do algebra, but I feel like the last one, like 2, and
Uh-huh.
is like, I have 37. I don't know. I don't know. I just don't know.
Me too, Serena. Me too.
Okay, and then I have 28 for 1, but I don't know how to do the negative ones. Really, I don't know. I don't know.
Well, first, good job. So
No.
you got you got both of them are correct. So that is a good job. So the negatives are tricky. That's why I give them both, right?
So
But
13
be
and
confident in yourself.
I
So
have
this
zero
is,
confidence with algebra, like 0.
well, you're 2 for 2, so that should increase a little bit of confidence. Those are both the 100 correct answers. The negatives, the reason I give them is because it really comes down. Yeah, and Kim has the right answer. How you put them in your calculator. So you got to be really careful with these, how you put them in your calculator. So
Well, I
when you
did the other ones in my head, so I guess probably if I used a calculator, I could figure it out.
when you go to put the negative in your calculator, you must put it in parentheses. You must. Because if you do not, your calculator is not going to square the negative sign. It is only going to square the number. And so this is a number that I always get students to, when I teach algebra, I always ask, what does -2 squared equal? And almost everyone tells me 4.
Isn't it not -4?
It is -4.
Okay, well,
And this is why you must put in the parentheses, because if I want to square -2 squared, that's where I get 4. So when we're dealing with functions, you must always put it in parentheses. So it's going to be 3 -2 squared plus 25. Well, -2 squared becomes 4 times 3 is 12 plus 25 is 37. And then if we do 1, we get 28. So if you did the negatives and you did not get 37 and 28, try it again in your calculator by putting the negative sign in and see if you do get 37 and 28. Do I sound like a robot or is it just me?
I think it's just on your end.
negative.
Yeah, I have a delay in my headset for some reason. Hold on one sec. Yeah, I have a delay in my headset. All right, see if that's better. Okay. I hope you said you all could hear me fine, but it was echoing in my ear, so it was messing me up bad. Felt like I was talking to myself. All right. So that's the key with the negative. So just be careful with how you put them in your calculator. And the easiest fix, make sure you put in the parentheses, as well as don't use the subtraction key, use your negative key. So depending on your calculator, usually it looks like this on your calculator, or it might look like that. That is for the negative signs on calculators. The little sign that's over here, plus minus, that, by times and divide on your calculator, the little group of 4, that is subtraction. Depending on how sophisticated your calculator might be able to differentiate between the two, but most calculators are going to have an additional key that's going to either have that or that. That's what you use to put in negative signs, right? Now, if you're like me and you like to use Excel as your calculator, then you can just type it in Excel. And I did 3 times and I listed out my little table here. So here's my X. Here's my F of X. So I'll do another one so you can see. You literally just put an equal sign in Excel. Call the cell you like. So equals. So the function was what? 3 times parentheses this value squared plus 25. And so what helps with Excel is once you have one formula, click on that cell, you got a big plus sign, drag it to the bottom right. You have a little plus sign, drag it down, and it just did all the calculations for me in one step. Now, I don't test you on Excel. You don't have to worry about using Excel, but if you like Excel and you've used it, you may use it for the rest of this course, because Excel is something I use in Chapter 5, Chapter 7, Chapter 8, and Chapter 9. Now, if you don't like it, don't use it. Use your calculator. But if you do, start practicing with it. You'll see that you'll find the answers a lot quicker. So now we've built this table. This is the tough part. No, besides the fact that I gave you the answer already. What is the domain, right? And it's already said it's all real numbers. I should have deleted that before I asked the question. But if you look at this function, is there any limits of what x can be? And so this is where it gets challenging, right? Because you got to ask yourself, you got to know your rules of algebra, right? Is there any rules against exponents? And the answer is no, right? X can be anything on an exponent. So since x can be anything, x is all real numbers. The issue is my function piece here, right? What do I get out? And so by doing some negative, doing the number 0, and some positive, I can start to see a pattern here. And I can see the smallest number is 25, and then it just goes up. Another way to see this, and I'm going to bring my box down here now, is by graphing it. And so if I graph this, so in OneNote, it's got this cool function. If I highlight the thing, insert math, I can tell it to graph it. And there is what it looks like graphed. And so this function is called what we call a parabola. It looks like a bowl. And you can see at 25 is my smallest value, and then it goes up forever. So my range is, my function is greater than equal to 25. And I haven't gone into graphing yet. We'll do that here in a second. Hawk's homework will have the graphs built for you, and you just got to be able to look at the graph and be able to interpolate it, right? If you're doing the projects, they will require you to do some of this stuff. So if, again, algebra is not your thing, Excel is not your thing, then that's probably a sure sign you probably don't want to do the Chapter 5 projects, right? Because again, they're not testable, but they are kind of fun. If I use my Excel, I can highlight my numbers. I can click insert, and then I can click a line chart, and it also creates it for me. Now, the reason these two charts look so different is my scale. My scale in OneNote is from 0 to -5, and my scale here in Excel went 0 to -2.5. Again, if I play around with this, I think I can change the scale. I don't want to spend a lot of time on this, but see if I can change it real quick so I can get them to look the same. Format grid lines, is that it? Yep. Nope. There we go. And it's still not as nice as theirs, but it's climbing. It looks like theirs goes up higher. How far do they go? 25, 30, 35, 40, 45, 50, 55. Yeah, it's just not going big enough. I can't, it's not making it go higher. Anyway, they're the same. It does look different because the scales are off, but.
I didn't see the other graph, the OneNote graph.
Oh, it's not showing you on the screen?
Didn't see it. Maybe it's just me, but I don't see anything else.
I think it's the one in purple.
Yeah, let me draw a line to it and see if you can see. If not, then I'll try to move things around. Right here. And maybe it's too far to the edge of my computer. So let me get rid of this and shrink it down.
Okay, now I see it.
Okay.
I think I just had the people in the way. Everybody was in the way.
Oh, yeah, that's. And again, you don't have to be able to use these cool tools. I do them just because they're better than me drawing by hand, right? If you want to see, if you wanted to do it on paper, how you do it is now we go back to the whole, you know, you draw where are we at? Actually, I'm just going to draw it with this. So I'm going to erase it. You know, you create an XY plane and then you plot these points. So over -2, up 37. So say 37 is way up here. -1 and 28. I'm doing a quick estimate, 0 and 25, 1 and 28. And we'll do a little bit more of this with lines here in a minute, but this is why I don't draw freehand, because my daughters are a real good artist. They did not get that from their father. I don't think I can draw a straight line if I had to, and I sure can't draw it. It seemed like a curved line at all. But rough estimate. I like using technology because then it's drawn to scale, but you can easily do these by hand as well by remembering how to graph in the XY system. And just a quick recap, I don't think it's really part of this course, but just talk about it. I'm clear my drawings. Get rid of this. Remember how to graph kind of XY. You know, this is called quadrant 1, quadrant 2, quadrant 3, quadrant 4. We always plot the independent variable value first, and then we plot the dependent. So even if I'm doing this in function form, always remember the independent is first, the dependent is second. Where these two lines cross is 0, 0. It's called the origin. And so just like the number line, when I go to the right, this is positive. So my value in quadrant 1, the independent variable has to be positive. It is y going up is considered positive. So all my points in the first quadrant are both positive numbers. Quadrant 2, I am going to the left on the x-axis, so that it is negative on the number line. I'm still going up, so that is positive. So points in quadrant 2, the independent is negative, the dependent is positive. Quadrant 3, again, I am going to the left, so my independent is negative, but I am now going down, so my dependent is also negative. So in that quadrant, they're both negative. And then quadrant 4, I'm going to the right, so it's positive, but I'm going down, so it is negative. So quick recap of how to plot. That's just a quick recap. So in this big takeaway, and like I said, I'll do some of the homework problems as well, but the key takeaway here is functions. Understanding what a function is, being able to look at a graph or a function and decide what can go in, what can come out, right? And then either given in table form or written out as an equation and asking you just to put in a value for X, can you solve it? And that really just does come down to using your calculator. And so it's good, especially for my nurses who are preparing for the T's, maybe to try to do the simple ones like Serena did, to do a few in your head just to practice your arithmetic, because on the T's you don't have a calculator. So doing a few of these by hand is good for you if you know you have to take the T's. So this is where you can get this class to help you prepare for the T's. If you're not having to take the T's and you just want to get through this class, then hey, you've already proven you can do it without a calculator. Then, so use a calculator, right? But you know what you need to get from this class. So practice it both ways, I guess, if you're my nursing students, then you still have to take your T's. If you finish the T's, then hey, use a calculator. But that's really all 5.1 is putting numbers into equations, understanding number goes in, that is your domain. Number comes out, that is your range, right? That's one of the values. Domain is everything that can come in. Range is everything that can come out. For most of our homework in this class, the domain and range, you're going to get a picture to look at and be able to look at the picture and say, hey, I can tell the smallest this is 25. If you take Math 100, or well, you want to take Math 100 because you're taking this class. If you take college algebra, sometimes you're going to get problems where you don't get graphs. And so a lot of times what you'll see with those type of problems is you got to understand what's going on. So a lot of times for domain and range functions, you either have a fraction problem or a square root problem. And then this is kind of understanding your concepts. So just a quick overview of this. Say I have a problem of 2 divided by x as my function, right? So f of x equals, oops, ran out of room, 2 over x. And now we got to think logically for a minute. So we know this is a fraction, right? Because it has a numerator and a denominator. What can you never have in the denominator? What can you never divide by?
Would that be 0?
0. So remember, when you look at a function, when you're doing domain, you're asking yourself, what can cause this to break, right? So x can be anything except for 0. So my domain x can be anything except 0. And then we get to kind of think about this kind of logically, right? The range. Well, we know we can't divide by 0. So what I always say when you're solving these type of problems, for a minute, allow the thing to happen that breaks the function, right? So then you ask yourself, right? I know I can't divide by 0, but if I could, what do I think 2 divided by 0 should be? And I know we can't, but if we could, if you could divide by 0, what do you think you would get? What would be the next logical answer?
2.
Well, 2 over 1 would give us 2, right?
Would it be 0?
Yeah, that's how I would go too, right? If I put 0 here, I would think, well, the answer should be 0. So since I can't put 0 in, I can't get 0 out. So then my function will never equal 0. All right, so sometimes you can look at the problem and be like, okay, if I can't put that number in, and I know I can't divide by 0, but if I could, I would assume the answer would be 0, so I can never get 0 in. Now, there is a whole class dedicated to just this. Serena's left, unfortunately, for public speaking. I had to take that class in grad school. When is 0 really 0? Love the professor. Great guy. Worst class I've ever taken in my life. It was so boring. It might have been because it was also at 5 o'clock at night and we could never, none of us could seem to even stay awake. But it is a very, very dry class. Is when is 0 really 0? And you might be asking yourself, why is that important? And it is important because of computers. Because a number that we say is 0, a computer is going to say it is not. And so we spend a whole semester talking about when is 0 really 0. And it does have real world applications. If we had more time, I could tell you about an issue with some military coding that the computer thought it was 0 and it wasn't, and we were missing our target. And we thought the equipment was broke, and it was because of this whole reason right here when 0 really wasn't 0. So square root's another easy error. I shouldn't say easy, but another one if you think about logically. So say we have, and we don't always have to use x, so I'm going to use not x this time. So say we have g of y, and this is where people really get frustrated with functions, because in algebra we always said y is what it equals. But remember, in function, all y is, the independent variable is the value inside the equation. So for our domain here is y, because it is the letter inside the equation, right? So now we have to ask ourselves, all right, this is a square root. What can we not take the square root of?
Zero?
You can. That is a common answer. If you go to your calculator and you take the square root of 0, you get 0. But you're on the right path. So I can take the square root of 0. What can I not take the square root of? Something less than 0, right? I cannot take the square root of negative numbers, right? If you go to your calculator and you ask it to find you the square root of -2, it's going to tell you it doesn't work. And we're going to, in our class, also pretend it doesn't work when it does, but we don't get to that till you get to pre-calc. So when you get to pre-calc, you'll learn how to do negative numbers. But for now, we're going to say you can't take the square root of a negative number. So I wish I could scroll down when I'm in draw mode because I keep running out of rooms that write so big. So again, what I can do is if I take y minus 2, that's what's under the square root. I know that that has to be positive. Well, for that to be positive, then that means the answer has to be greater than 0. But I think it was Julie who just said, well, can 0 work? Well, we said it can. So therefore, I know what's inside the square root has to be positive, which means it has to be greater than equal to 0. Now, if I solve for y, oops, add 2 to both sides, I get y is greater than equal to 2. So my domain is y is greater than equal to 2. Because if I pick any value less than 2, I will get a negative number and I break the function. So I know I have to be greater than 2 because my answer must be positive. So now we go to range. Right? Range, well, if I put a 2 in, so say I solve for 2. So I put the worst case scenario in, right? Just like I did up here. I put the worst case scenario in, 0, even though it wasn't allowed. I put it in to give me an idea what's going on, right? Here, the lowest I can put in is 2. So if I put 2 in, 2 minus 2 is 0. And if you go to your calculator and you type in the square root of 0, you will get 0. So the smallest number could go in is 2. The smallest number that can come out is 0. So therefore, my range, g of y, is greater than or equal to 0. So those are the toughest, right? Because there's no picture, and you have to understand what's going on. This is like the limit of this section for our class. Math 122 college algebra goes way deeper into this. This is our stopping point for here for domain and range. What I want you to get out of this class is being able to look at a picture and tell me what's going on, and being able to take values and put them into an equation and to solve them to give you an idea based on knowing what the function is doing. Can you tell me domain and range? All right, so that's kind of the key takeaways there. And again, even if you're doing the projects, 5.1 might be a good lesson to not go certified, but just go ahead and go practice a few times just to make sure that we're comfortable understanding these definitions, right? You don't have to certify, but go and do a couple practice problems, get that foundation under you. And then when it comes to the test, you do the chapter review test, the practice test like I created this time, and those concepts kind of come back to you. Any questions on 5.1? All right, 5.2, how are we doing on time? Okay. It's definitely where we'll stop down. I don't know if we'll get through all of this one. But most of you probably have seen lines before, right? And usually, typically, if I ask a question, what is the equation of a line? The most common answer I get is y equals mx plus b, right? And that's because that is how we've learned it in previous algebra classes. There's actually multiple equations for lines. But we will stick with this wonderful y equals mx plus b for now in our class as well. And so I give you the equation here, y equals mx plus b for the equation of a line. And so x, because it is the variable in the equation, is our independent variable. Y is what it equals, so that is our dependent variable, and M and B are what we call parameters. They are placeholders in the equation until you give them values. Until M and B have values, you do not have the equation of a single line. Once you put in values for M and B, you now have the equation of a single line, right? X and Y, there is infinite values for X and Y. They are variables. They stay X and Y. M and B, though, become a number to be able to actually create the function. So right now, this is kind of a generic form. I have to give M and B values for this function to be complete, right? So M has its own equation, and it's called the slope. And a lot of us remember it as the ratio to rise over run. It is also called the rate of change, right? And what you do is you take 2 points and you take your Y values and subtract them, and then your X values and subtract them, and that gives you a ratio for rise over run. And basically rise means to go up or down. So I go up or down, depending if it's positive or negative. And then run, think of it as like on this sports field, you're going left or right. So if you're going right, positive, left, negative. And so I can see how quickly my line is increasing or decreasing, depending on if it's positive or negative, right? So that's how you find M. B is what we call the y-intercept. I probably should type that in here. I'll add it afterwards, but due to time, I'm just going to write it in for now. And all that is where the line crosses the y-axis, where the line crosses the vertical line. And so B is a point. It is the point 0, B. So if I know the point, where a line crosses the y-axis or the vertical axis. So this is up 3. So in this case, this is the point 0, 3. So that means my B value for this equation would be 3. So by knowing where your line crosses that axis, I can quickly find the value. Now, we don't go too deep into that again in this class, because again, we just scratch the surface on multiple topics. You take college algebra, you'll find all the different ways to find that answer, right? But for us, being able to look at a graph and realizing where that thing crosses is the point. Or if I tell you B equals 3, then you know that is a point on that axis, right? And so we can rewrite this thing as a function, as instead of using y, put in f of x equals mx plus b. Nothing's wrong with that. Just like I said, there's nothing wrong with just making it a y. Because again, x is the variable inside the equation, so that is the independent value. What it equals is the dependent value. Now, a line goes on forever. So what is its domain? So the domain, all real numbers. Because it goes left and right forever, x can be anything. And my range is also all real numbers, because it goes up and down forever, right? If I have a slope, I have a rise over run, right? As long as I have a slope, my line is climbing, either positive or negatively. So therefore, for my lines, my range and domain are always the same. Lines are the easy one, all real numbers. And so again, I have another shipping cost problem, right? which we just did again, but here's another shipping cross problem. Shipping cross problems are linear, right? They increase at whatever the fee is. So in this case, my slope is 15 cents, right? And so I wrote this out as an equation like this, but if I want to write it in y equals mx plus b form, I can say, well, I know it increases at 15 cents. So that means 0.15, oops, that's ugly 5, has to be my slope because that's how much it's increasing by. And then where it crosses the line is where I am at the spot where I don't increase, which means the charge of 375. And so I wrote it out as a function based on the wording. But if I actually solve my equation, like get rid of the parentheses and distribute, I will get back to that answer. Now, they're a little off because, again, I have this weird domain because, again, we have over 5 pounds. So that's why we kind of stick with. Now, if I didn't have anything over 5 pounds and I said everything costs that, then this thing would work out a lot nicer. But they are linear. We're doing time. Okay, we're okay. So another problem here is simple interest. Simple interest is a linear problem. And I think we have a couple homework problems using simple interest. So the simple interest formula is I equals PRT, where P is the principal, rate is your interest rate, and T is time. And this is where a lot of people, when they first use this formula, get confused. They think I for interest is your rate. Now, the percentage is your rate. Interest is how much you pay, right? So the way I write it, as I put this out in kind of words, so P, I like to think it as my starting balance. Where am I beginning? And then R, again, is my interest rate as a percentage, and T is how long I am paying on something. And we'll really get into this in chapter 9, but it also fits in here real nicely because it is a it is a linear problem for simple interest. And so if I want to solve it, say I have a starting balance of $1,000, my rate is 1.5%, and it's going to be in there for 5 years. So I'm saying I'm investing money into a decent savings account, and I'm just going to put $1,000 in there and not touch it for 5 years, right? And so that uses simple interest. So to figure out how much interest I earn, I just take 1,000. I multiply that by the percent. And again, you got to take that percentage back to chapter 4 and turn that into a decimal. So that becomes 0.015. Remember, move it 2 places or divide by 100. So back to chapter 4 a little bit. And then I multiply that by 5, right? So bring up my calculator, 1,000 times 0.015 times 5 equals 75. And then all these next A, B, and C is just if we had time to go through and just put in different years, right? So do times 2, times 4, times 8. Yeah, we're cutting close on time here. I think so just use the slope formula. Instead of doing the whole thing, I'm just going to do the slope formula here. So the slope formula is change in y over change in x. And all that means is you take 2 points, right? So say I want to calculate the Fahrenheit formula, Celsius to Fahrenheit. So we're going to say Celsius is x, Fahrenheit is y, right? So I pick 2 points. So I'll take the first 2. So 212 minus 100. No, God, I messed that up. Not minus 100. It's change in y over change in x. So don't do what I just did. 212, and then I put 100 on the bottom. So the way I like to make sure I don't make the mistake I just made is put the y's on top, x on the bottom, and you line the points up vertically. So when I put the y, I put its x right below it. And then I take my next point, so y is 122. And then my x is 50. And now again, if we go to type this in your calculator all at once, make sure you put parentheses around those. So your calculator can do them all at once, or you can do each piece individually. It's completely up to you. Just make sure if you're gonna do it all at once, you put in those parentheses. I'm gonna do them individually for now. So that's 90. And then 100 minus 50 is 50. And then I reduce that down to 9/5. So that's how you find slope. You just pick two of the points, subtract the y's, subtract the x's, making sure you keep your points aligned. Don't make the mistake I made a few seconds ago. And I have my slope. Now to find the b, remember our b is the point 0b. Well, if I come down here, you can see we have a point that has a 0 in it. So that means b is 32. So if I want to make this equation, remember y is f, so I'm going to call this f equals my slope 9/5, and then times my x, which is c, plus b. And if you look up the Fahrenheit formula, that is the Fahrenheit formula, and that's how it was calculated. You know, they took a bunch of different temperatures and found out there is a ratio, there is a change, and that change is 9/5 based on the freezing point. So if you never remember the Celsius or Fahrenheit formula, then now you know actually how to calculate it yourself. All right, we got about 4 minutes. I want to finish this out. So this is one of the problems from the homework. I copied it. So we'll finish here. So you can purchase a car for 19,920. I copied this right out of Hawk. So yours numbers would be different because it changes the numbers. Or you can lease it for $320 per month with a down payment of $400. So how long can you lease your car before the amount on the lease is more than if you would have just originally bought the car, right? So how will we attack this problem? Well, you got to look at the problem and see what is the different pieces. So $320 per month, that is a change. That means my m, my slope, is the 320. And my starting point is my b, which is the 400, right? So now if I know this is linear, I can say 320. And I'll put x in here again, just because we're used to using x. You could put m for month if you want, plus the down payment of 400 equals y. So there's our equation. However, we know what we want y to be in this case. We want it to be 1920. Right? So now if I put that in for y, and we want to know before the amount is more than, so I put a more than sign in my equation. Right? Now, solve for x. So I subtract 400 from both sides. All right, so 19,920 minus 400 equals 19,520. Well, I should have been able to do that in my head, but it's been a long day. Is less than 320x. Divide both sides by 320. So 61. So 61 months is the cutoff. So if you're going to buy a car and you want to know if it's better to lease or to buy it, well, ask yourself how long you're going to have it. If you're going to have it for less than 61 months, you'll actually save money leasing it. If you're going to have it longer than 61 months, you would actually save money purchasing it. Now, there's way more to it than the linear function. This is basically a simple problem to a hard real problem. We'll learn about the lovely formulas for buying cars in chapter 9, but this is kind of a simple attack to this problem. The brisket problem, maybe I'll start there. This is a cool way. This will help for the chapter 5 kind of project. And then so next week we will go into other types of models, which we already did a little bit today. Quadratic is the formula for a parabola. We've already played with him a little bit today. And then we'll do exponential and logarithmic. Again, those are just 3 different types of models that we'll kind of scratch the surface on, that college algebra goes in much deeper on if this is something that interests you. As always, I took the entire time, but I am still here if anyone has any questions.